So here's part 2 of the exponent properties. The next property we're going to talk about is called your quotient property. That's when you have a quotient, and when you have a quotient, that means you are dividing. So let's say we have x to the 6th over x squared. If you remember with your product property when you were multiplying and you have the same base, you add the exponents. Well, what undoes multiplication? Division. So since we have division, instead of adding our exponents, we're going to subtract them. So find the side, or find the part of your fraction or your quotient here that has the largest exponent, and then subtract the smaller exponent from it. So since our numerator has an exponent of 6 and a base of x, our denominator has an exponent of 2 and a base of x, our bases are the same, we can simply subtract those exponents. So 6 minus 2 is 4. Since my larger exponent originally was on top, my solution is also going to be on top, okay? And since all we're left with in the bottom is a 1, we don't have to write that. So the solution for this problem is x to the 4th. Now if we write this out in expanded form, x to the 6th is 6 x's. 1, 2, 3, 4, 5, 6. That's multiplication, okay? Over x squared, which is x times x. Now here's how this works. So basically, when it's written out in expanded form like this, if you've got x over x is just 1. So again, x over x, 1. And then you're left with how many x's on top? 4. Okay? This is just a simple rule of fractions. You know, if you have 2 over 2, what does that equal? It equals 1. So if you look at it individually here, x over x is 1, x over x is 1. Okay? And you're left with x to the 4th on top. Let's look at one where the denominator has a larger exponent. Let's say we have y to the 3rd over y to the 8th. So in this case, since our larger exponent is in the bottom or in the denominator, I'm going to just subtract going upwards, okay? So 8 minus 3 is y to the 5th. Since my larger exponent originally started in the denominator, my solution is going to end up in the denominator. So since I did 8 minus 3, my 5 is going to end up in the denominator. Well, you can't just have it nothing up top, so you got to put in a 1. So your solution for this particular problem is 1 over y to the 5th. If we look at it in expanded form, we have y times y times y over y, 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 y. I think that's 8. All right, and again, we can just cancel out what we have in common in the top and the bottom. There's a y and a y, a y and a y, a y and a y, 1, 2, 3, 4, 5, left in the bottom. So my solution is still 1 over y to the 5th. Next property we're going to look at are negative exponents. Let's say you just are given y to the negative 2 power. You never want to leave a power written with a negative exponent. You always want to end up simplifying it so that there are positive exponents. So here's how you deal with this. First of all, you turn this into a fraction. If it's not already in a fraction form, turn it into a fraction. So how do we turn this into a fraction? We draw a fraction line underneath it, put a 1. Okay, now this is important. You're going to move. Anytime you have a negative exponent, you're going to move the power across the line. It's very important here not to say flip. No. Flipping is bad when you're dealing with negative exponents. We are moving. Okay, moving the powers across the fraction line. So, moving. Yay, that makes me happy. All right, flipping makes me sad. So, no flipping, only moving. So we're going to move this across the fraction line. So that's going to end up with 1 over x squared. So some of you are sitting there going, but Miss Fowler, that looks like flipping. Yeah, it looks like flipping, but it's really not. It's moving. Let me show you. Let's say we have, x to the negative third y squared over x to the fifth y to the negative 3. Okay. Not all of my exponents are positive. Not all of them are negative. We only move the ones that are negative. So I'm going to go ahead and write my solution fraction line over here. And let's take one at a time. Let's say I have x to the negative third. Well, that is a negative exponent. I want it to be positive, so I'm going to have to move it across the fraction line. All right, so let's take that x to the negative third, make it positive, and move it across. Okay? Now, if I look at this y squared, it's positive. It doesn't go anywhere. It stays exactly where it is, okay, in our solution anyway. So it stays up top. Let's go to the bottom. I have x to the fifth power. That is a positive exponent. It stays where it is. It does not move across the fraction line. So it's going to be in the bottom down here. Y to the negative third. Negative exponent is going to move across the fraction line. Okay, now we can simplify. If you notice here, we've got same base, positive exponents. Add those exponents together, you get y to the fifth. In your denominator, x to the third times x to the fifth, positive exponents, same base, you get x to the eighth. If you had flipped these instead of moving what needs to be moved, you would have ended up with the incorrect answer. Okay, so your solution is there, y to the fifth over x to the eighth.